Today we're going to look at the factor theorem, an extension of the remainder theorem. Now, if I know that x plus 3 is a factor of fx, okay, I can write it as fx equals to x plus 3, the factor, times the quotient, okay, plus the remainder. However, since x plus 3 is a factor of fx, the remainder must be equals to 0. Right, equals to 0. Okay. Okay. For example, for numbers, we see a parallel. Okay. If 5 is a factor of 45, then obviously 45 is written as 5 times 9 plus 0. Okay, that's the remainder is 0. Okay. Back to the example of polynomials. So in this case, if I let x to be equals to negative 3, I get negative 3 plus 3 times q of negative 3, it will give me 0. Okay. So x plus 3 is a factor, would imply that f of negative 3 is 0. However, similarly, if I can find a number and I substitute in the polynomial and gives me 0, this will also imply that it will be a factor of fx. Now let's illustrate this with an example. Given that x minus 2 is a factor of this polynomial, find the value of k and the remainder when the expression is divided by x plus 3. So let's tackle the first part first. Okay, firstly, let fx equals to the cubic polynomial. Since we know that x minus 2 is a factor by our factor theorem, f2 is equals to 0. So in other words, if I substitute 2 into the expression, this will give me a 0. Okay, and I can solve for k. K is equals to negative 26. Okay, so we have addressed the first part of the question. The second part, we still need to find the remainder when the expression is divided by the linear divisor x plus 3. So we know that fx is now equals to 3x cubed minus 2x squared plus 5x minus 26. So by remainder theorem, the remainder that we require is actually f negative 3. So all we have to do is to substitute negative 3 into fx. Okay, so we get 3 negative 3 cubed minus 2 negative 3 squared plus 5 negative 3 minus 26. Okay, and this gives me negative 140. Right? So with the factor theorem and the remainder theorem, we can solve polynomial problems involving quotient, remainders, and divisors.